to be able to share with you some facts and expectations about the solar eclipse. I hope everyone can hear me okay. I'm going to start my screen share. I'll be switching between some various different programs, so just be patient. I will try to do that as efficiently as I can. But I'm going to start with a few slides about solar eclipses, and then we can show you a few of the demonstrations I have here in the room with me, including binoculars with special eclipse film. Okay, and I want to also thank Brian Dunn, who provided a lot of these slides because he's one of our big teachers in the department and has given these talks for many years, including back in 2017 when we last had a solar eclipse here in Illinois. So I'm going to try to cover three main topics in my presentation, and then we'll have time for your questions as well. The first topic is, why are solar eclipses special? Why don't they happen all the time? Second topic is, what does a solar eclipse look like? So give you a little bit of expectation about what the experience is going to be like. And then finally, and very important, especially for parents with kids, how can I watch the April 8th eclipse safely? Okay, so we'll start with a little basic astronomy, which you may have learned at some point, but maybe it was a while ago. The Earth is orbiting the sun, and the moon goes around the Earth. And once in a while, the three bodies are going to be in line together. See if I can actually get my pointer. Yeah, I don't seem to have a pointer on my computer here. I always have a little trouble when I'm doing Zoom on a keynote presentation. Let me try again. Okay, well, yeah, unfortunately, I don't have my pointer on the screen. But what you can see here is that the moon has a shadow, and the shadow basically touches the Earth, right? And so when you're in that shadow, then the moon is blocking the sun, right? And that's what a solar eclipse is like. Now, in order to get this to happen, though, the three bodies have to be in line. And it might seem like that's very easy to happen, but it actually is quite hard because they're actually very far apart from each other. This picture is not accurate at all. The moon and the Earth are very far apart, and the sun is even further away. And so because of the way the moon orbits the Earth, the moon doesn't always get exactly between the Earth and the sun, and we don't have a chance to see an eclipse. So I think the other important thing that I want to get across here is that the fact that the moon is the right size to block the sun is actually a huge coincidence because the sun is actually much, much bigger than the moon, right? The sun is like this big orange ball, and the moon is that really small dot that you see off to the right. Okay, so if you put the sun and the moon next to each other, you could barely see the moon, right? But it turns out that because the moon is closer to the Earth than the sun is, they're about the same size, right? The sun is 400 times larger than the moon in width, but it's also 400 times farther away. And so when you look at them in the sky, they're about the same size, okay? And of course, you don't usually look at the sun directly. It's very dangerous. But sometimes on a kind of a cloudy day, you'll kind of see the circle of the sun through the clouds. And it looks really about the same size as the full moon does, right? And that's really because of this enormous coincidence. So if the moon were to actually come in front of the sun, which is what happens during a total eclipse, then you have this circle of the moon that just blocks exactly the circle of the sun. And that's a very exciting event. Why is it so exciting? Well, we know that the moon goes through these phases, and to kind of give you an idea of how phases work, we have a little animation here to kind of show you um, how the moon orbits the Earth. And in this animation, you can see that the moon is going around the Earth once a month, and the Earth is turning around once a day, and the sun is over here on the left side of this picture. And I'm going to speed it up a little bit so you can see it more quickly. You can see the moon go through these phases, right? The moon looks different in different times of the month because when we're looking at the moon, we're always seeing a moon that's half bright and half dark, but the part of the moon we see changes throughout the month. So sometimes we're mostly seeing the dark side, and sometimes we're mostly seeing the bright side. And that's why the moon changes its appearance. We see these different phases. Now, when you look at this picture, you would think that when the moon comes over here, which is once a month, that's a new moon, that the moon would block the sun, right? It looks like it has gone between the uh, basically between the Earth and the sun. But it doesn't exactly line up most of the time. That's because the moon's orbit is a little bit tilted. And as a result, the moon usually comes above the sun or below the sun. We can't see it because it's during the daytime, so you won't be able to see where the moon is. But it's very uncommon for the moon to actually come exactly between the Earth and the sun. Okay, so this picture here kind of shows this as well. Uh, This is on the left here, you have the new moon. On the right, you have the full moon. And you can see that the orbit of the moon is a little bit tilted. So when the moon's shadow is above the Earth, then it's not touching the Earth. And it's only when the moon is exactly in line with the Earth and the sun that the moon's shadow will touch the Earth. Okay. And so we don't see a solar eclipse every new moon because the lineup is not correct. And we don't see a lunar eclipse every full moon because, once again, the full moon basically gets below the Earth's shadow or above the Earth's shadow. It doesn't get inside the Earth's shadow. It's only if the full moon goes inside the Earth's shadow that we see a lunar eclipse, right? So you might have seen a lunar eclipse. It's not that hard to see. It's when the moon goes dark in the middle of a full moon, and sometimes it looks a little bit red, and so it's kind of exciting. Okay, but much more common to see a lunar eclipse than a solar eclipse. And why is that? Well, because the solar eclipse, if you look at the picture on the bottom, it's only seen in a very small part of the Earth. And let me try to show that on a different picture as well. See if I can find it. Yeah. Okay, so here's the moon and its shadow. And you can see that normally during an eclipse, the moon's shadow is just barely touching the Earth. So there's really only one place on the Earth that is seeing the solar eclipse, right? And then everything else is seeing a partial eclipse, and that is the Earth is, I'm sorry, the moon is blocking part of the sun, but not the whole sun. Whereas when the moon is in here, inside the Earth's shadow, then everybody on the night side of the Earth can see the dark moon. And so that makes the lunar eclipse a much more common experience to see because everyone on this side of the Earth can see it. Whereas when you have a solar eclipse, it's only people at this exact spot that are able to see it. So this diagram here also kind of gives us an idea of how the moon's orbit appears, because you can see that when we look at the orbit edge on, it is kind of tilted. And so the moon is not exactly blocking the Earth or blocking the sun, except when it just happens to be crossing that special location. Okay, and so we have special names for the different parts of the shadow. The dark part of the shadow is called the umbra. The light part of the shadow is called the penumbra. Astronomers like to name things. There's all kinds of different names that we use. Don't worry about it. Just the main point is that the dark part of the shadow is where you want to be because that's the place where you really experience darkness. If you're in the light part of the shadow, then part of the sun gets blocked. But the sun is just so bright that even if you block half of the sun, it still looks like daylight, right? So you really have to go into the dark part of the shadow to experience the true wonder of a solar eclipse. So the three basic types of solar eclipses are shown here. The total eclipse is the one at the top. That's the one that's most exciting because the entire sun gets blocked. If the moon is a little bit too far away, though, then it's not big enough to cover the sun. Why does the moon get farther away? Well, it turns out the moon doesn't make a circle around the Earth. It actually makes an oval. Sometimes it's a little closer and sometimes it's a little farther. And if it just happens that it's a little farther than average during the time it comes in front of the sun, then it's not going to be able to block the sun entirely. So you'll still see a ring around the sun, even if you're in the right spot to see the eclipse. So we had an annular eclipse just in October. You might have heard about it. Unfortunately, the weather was not good here in Champaign, so we couldn't actually go out and watch it. But people in Texas had a really nice view and in New Mexico. And then the bottom picture here is showing you a partial eclipse, which is what we will experience in April if we stay here in Champaign. If we want to see totality, we'll have to travel a little bit, and I'll show you a map of how that works. So what does the eclipse look like? Well, it goes through different stages. And so basically, this diagram kind of gives you an idea of the different stages. First, a little bit of the moon starts to cover the sun. And of course, the sun is still too bright to look at. So in order to see this part of the eclipse, you're going to want to wear your special eclipse glasses, right? Like this, okay? Except I don't want to talk like this because I can't see anything when I'm wearing them, right? So when you're wearing your eclipse glasses, you won't be able to see anything around you, but you will be able to look at the sun because these are very dark glasses. So as the eclipse progresses, the moon blocks more and more of the sun. And if you're lucky to be in the path of totality, then eventually the entire sun will get blocked, and that's called totality. That lasts only a few minutes, and then the moon starts to move again across the sun, and you have the rest of the partial eclipse. So the whole duration is about 2 hours from the first to the fourth contact. But the totality phase is only about 3 minutes. So that's the most exciting part. Right before totality begins, there's the last bits of the sun visible through around the moon. And you can sometimes get this phenomenon called Baily's beads. That's when a little bit of the sun's surface you can still see. And because the moon is not exactly smooth, it has these mountains and stuff. You get these little bits of light at the edge. It's very, very interesting to see. And then right before the last bit of the sun disappears, you have what's called a diamond ring effect, where you just have one little piece of the sun visible before it completely disappears. And then after totality, it's the same in reverse, so that you get another diamond ring on the other side of the moon, and then you can maybe see more before the entire crescent of the sun appears. Here's a picture of what's called a double diamond ring. There are people that are very excited about eclipses and chase them all over the world and take lots of exciting photographs. But unless you're very good at taking photos of the sky, and I'm one of those people that's not good at it. Some of my colleagues in the astronomy department are very good at taking these pictures. I'm not. And so if you're not good at taking these types of pictures, don't waste time doing it. Just enjoy the show. It's something you want to experience with your own eyes. And then afterwards, you're going to find all kinds of great pictures that other people have taken. So the most exciting thing about totality, of course, is that when the moon has blocked the sun entirely, then there's a part of the sun that we never see that comes out, the corona. That's this sort of whitish stuff you see in this picture here that surrounds the sun. It's actually the outer atmosphere of the sun, and it's extremely hot. It's even hotter than the surface of the sun, but it's also very thin. And so we don't see it because it's outshone by the rest of the sun. So only when we block the main part of the sun can we see this part of the sun we call the corona. So at the edge of the disk, you can also sometimes see little bits of gas that are coming off the sun, like solar flares. So one of the things that scientists like to do is take these pictures and study them because we never quite know what the corona will look like until the eclipse happens. And so getting to see the corona and actually seeing what it looks like is one of the most exciting things for the astronomers to do. Okay, and you'll see wonderful pictures like these that people take using special techniques. It's a little bit weird that you can do this, but photographers are very clever at putting these images together. One of the other exciting things about an eclipse is that you can actually see some of the brighter stars and planets come out because when the sun is blocked, the sky doesn't become as dark as night, but it feels a little bit like sunset, okay? And it's a weird sunset because it happens all around you. It's not just in one place. You have basically a circle of darkness above you, and then at the edge of that circle is still in daylight. And so it's this weird experience of having a sunrise or sunset in all directions around you. And you can sometimes see some of the brighter stars and some of the planets as well. So totality is a really fun experience. I was fortunate to be able to see a total eclipse in 2017. Some of you may have seen that as well. And so it's exciting because of the darkness, but also because you get to see this special region around the sun called the corona, which we never see. And if you listen and you experience the moment, you'll notice other weird things like the birds behave differently, the temperature changes, and usually if you're with a group of people, they're all going to be screaming and shouting because it's so exciting. So there are many accounts of eclipses that you will find online. I thought I would share maybe one example, which is from the Veritasium site. This is done by a scientist who likes to share his love for science on YouTube. And I'll show you, let's see, I need to share the audio thing here. And let's see.
This is insane right now.
Can people hear the audio from the video?
This is just unbelievable. What?
Oh my
god! What is happening? This is absolutely insane.
You can see these people are watching.
I feel like it's hard to breathe. Oh my god. This is so totally creepy.
Oh my god, the sun! The 360.
Oh my goodness. This feels so weird.
Look at the sunrise, Derek. It's every direction.
Oh my goodness. There's like sunset, sunrise, every direction. People are going nuts. This I did not expect. I don't know what I expected, but
Oh my God. Guys,
this
look
just
at the
looks
sunrise.
so wrong. You can see these prominences, the solar corona coming out, the top left and right and the bottom.
Okay, so that's an example of some footage. And so someone asked on the chat, will our smartphone be able to capture the solar eclipse? And the answer is it's going to be difficult because the smartphone is not designed to magnify small objects, and the sun is actually quite small in the sky. So you're not going to see as nice a picture of the sun as you do here. On the other hand, if you are looking through a telescope at the sun and you can look through the eyepiece, then sometimes you can actually put your phone on the eyepiece as well to take a picture. Just try not to take too much time to do that if there's a line of people waiting behind you. Okay. But again, I think the most interesting pictures I took during the eclipse or videos were not of the eclipse itself, but of just the other people and the kids around me and how they were reacting. So that was the part that thought was the most fun. Okay, so let me find the rest here. So I want to talk a little bit about the path of the eclipse because as I was saying, there's only a part of the Earth that sees the shadow. The shadow is like a spot. And the shadow basically travels across the Earth because the moon is in motion around the Earth, and the Earth is also in motion as it turns. So people will draw these maps that show you the path of the eclipse, like you see here. But it's important to realize that at any given moment, it's only a small circle that is experiencing the eclipse. Okay. So here's a movie of what's happening on April 8th is the moon's shadow is going to move across the Earth at the same time that the Earth is turning. Notice the shadow is moving in basically a straight line, but because the Earth is a sphere, that straight line becomes a curve on the surface of the Earth. Okay, and notice how quickly it's happening, right? So although this time is sped up, the whole thing only lasts a few hours. And so that spot on the Earth is moving over the surface of the Earth at something like 1,500 miles per hour. So it's moving at supersonic speed. So even if you were on an airplane trying to follow the eclipse path, you could not stay inside that path unless you were maybe in a fighter jet or something like that that can go at Mach 2. So the ability to experience the eclipse is just limited to that very narrow path. Okay, and there are other really nice animations that you'll see as well. This one I like too, which actually shows a map, and you can see this dark spot moving across the Earth. So it's almost like you're flying with the dark spot. Here it makes landfall at Mazatlan, which is a nice tourist city in Mexico on the Pacific. And as it moves further to the northeast, you'll see that it passes over some various parts of Mexico. And as it continues, it's going to go into the United States. Let's see, not quite yet. Okay, so just coming up ahead, it's entering the United States right around here. Okay, notice the speed of the moon's shadow is about 1,600 miles per hour. We are now in Texas. We are going past the suburbs of San Antonio. We also get totality in Austin, Texas. Some of these other cities like Killeen and Waco are closer to the center, and so they'll get longer totality. Dallas Fort Worth is a little bit on the side, so it's a little bit shorter for them, but still a great experience. So if you want to go to Dallas, that might be a good place to go. Now we see the shadow enter Oklahoma and Arkansas, and we're going to pass by Little Rock, Arkansas. And as we continue, you'll notice the duration of totality is changing slightly. That's over here on the left. That's about 4 minutes now. And we are now entering Missouri. Okay, we're going through the southeast corner of Missouri, and now we're entering Illinois. So this is Southern Illinois, Carbondale, Marion, some of these other small towns. And Effingham's over here, Champaign's over here. We're not in totality. Now we're entering Indiana, Terre Haute, Indianapolis, Bloomington, Indiana's down here. And now we're entering Ohio. And notice that the speed of the moon shadow is speeding up. That's because the moon shadow is now getting elongated as the Earth turns around. And so the shadow is moving much more quickly now. And so the duration of totality is also going down. We're now passing through New York, Buffalo, New York, Niagara Falls, Ontario, Canada, just missed Toronto, but other Canadian cities like Kingston and Montreal do get to experience some totality. We're now in upstate New York. We're entering Vermont and Quebec and New Hampshire. And then in Maine, we're getting very late in the afternoon. And so the sun is starting to set. And so by the time the path of the totality has reached the most eastern parts of North America, it's getting very close to sunset. And so the eclipse ends at the edge of Canada here in Newfoundland. Okay, so this is kind of a fun map to look at. And you can find this and much other information at this site called Great American Eclipse. Okay, if we want to focus more closely on our areas, there's another website called eclipsewise.com, which I recommend. And you can get information about pretty much any eclipse, but this is the information about April's eclipse. And so I'm going to zoom into this Google map. And you can see that they've actually drawn the path of totality here very nicely, so you can see where you are compared to that. So here we are in Champaign-Urbana. And so if we want to see totality, we have to go south or we have to go east. Okay. And so you can't see it here, but we're going to see a partial eclipse. So some of us at the astronomy department in Illinois will be going to Terre Haute. It's relatively close by. But there are other people that are going south to this area called Marion. And you never know about the weather. So hopefully one of the groups will be lucky and get some clear skies. Okay. A lot of people are going to go to Indianapolis, right? And so for people in Chicago, that's probably the most convenient place to go. Just be aware that if you go to Indianapolis, it's going to be very busy and there's going to be a lot of traffic going home. So just be prepared for a long trip. And then, of course, if you want to have the best chance of clear skies, you want to go as far towards Mexico as possible. So people in this southwest part of Texas are probably going to have the best chance of clear skies. But you never know. I think it's too early right now to know whether the weather will be good or bad. There's some indication, but during the next week or so, we should get more confident forecasts, and then you can start to think about where you want to go to watch the eclipse. Just bear in mind that hotels are going to be very expensive near the path of totality. Okay, what else? Okay, so I did want to spend a little time talking about how to watch the eclipse safely, because I think that's very important. I just showed you these eclipse glasses that I have. and they look like what you see on the right here. Do not use regular sunglasses. They're okay for driving. They're not for looking at the sun. Okay, so do not wear regular sunglasses. On the other hand, you'll sometimes find online special glasses which are designed for looking at eclipses. They look like sunglasses, but they're much darker. Okay, and so if you want to look a little bit more fancy, you can wear something like that. Okay. There's a safer way to enjoy an eclipse, and that is using what's called indirect viewing or pinhole camera. And so I have an example here. Let me stop the zoom so you can see more clearly. Okay, so what I have here is just a cereal box, but I've cut open a hole on both sides of the top. So this is basically, this side, the hole is a way of looking into the box. And then on this side, I have another hole, but I've covered it with aluminum foil and put a little hole, pinhole in the middle of the foil. So just using a needle, right? Just poke a little hole. So then what you're going to do is you're going to look through the big hole, and you're trying to get the sun's light to go through the little hole and make an image at the back of the cereal box. Okay. And if you line things up, okay, you have to be facing away from the sun. But with the sun behind you, the sun's light goes through the pinhole and you can see a little image of the sun. Now, normally when you do this, the sun will just look like a little circle. But during the eclipse, the appearance of the sun will change, and that's going to be very interesting to watch. And that's going to change over that 2-hour period. And so we can use this kind of method to watch that change. Okay. And it's really simple to do. It's a great thing for kids to do. And you can test it out on a sunny day without, any kind of danger. You just have to make sure that you cut the holes on both sides and you cover one side with the aluminum foil. A little bit fancier is this tube. So this is a long tube, and we've put aluminum foil at the end. And again, we've poked a hole in the middle of the foil. So the idea is to get the sunlight to go through that little hole and make an image at the bottom. Now, at the bottom, we have a little hole we've cut out so that we can see the image, right? Because we can't put our head inside the tube. But if you look through this rectangular hole, you can see the image of the sun at the bottom. Okay. Now, you have to line it up exactly right, though. So that's the problem with this method. You get a bigger image of the sun, but you only get it if you line up the sun properly. So the way to do it is to look at the shadow of the tube and try to make the shadow as small as possible. And that'll tell you that you've lined it up properly. Okay. So this is something that older kids might want to give a try. And then here I've got a pair of binoculars, which I've put some special solar filter film on top of. So you can buy this solar film on Amazon for a few dollars. And if you have a pair of binoculars, you can just cover both of the lenses with this film. And again, you can test it out on a regular sunny day, make sure that it works. And so you can actually watch the partial phases of the eclipse through the binoculars as well. Okay. If you do travel to totality, though, make sure that you do take off your glasses during totality, because during totality, it is safe to look at the sun. The sun is completely blocked except for that corona, and the corona is only as bright as the full moon. And so it's actually quite safe to look at. And if you keep your glasses on, you're going to miss all of that excitement. Okay, so let me see if there was anything else that I It's just reminding us not to look at the sun. That's the cardboard tube. Here are some places to get Eclipse glasses. Oh, by the way, the Champaign Library is giving out Eclipse glasses from April 1st. So if you don't have some already, you can go to the library to pick some up. I'm sure they're going to run out at some point, but if you go early, you should be able to get some. And another thing that you might look out for is just walk around during the partial phase and look at the trees because normally as sunlight passes through leaves, it just does its normal thing. But when you have the sun in eclipse, you can actually get this weird effect where the leaves of the trees act like lenses and produce little images of the sun. So that's kind of cool. Okay, and then a few fun facts as well. So it takes about 375 years on average for a total eclipse to happen again at a same location. Actually, we're not going to have to wait quite that long here in Champaign. It turns out that there is a total eclipse that's passing through Champaign in the year 2153. So if you don't mind waiting 130 years, you can enjoy this total eclipse right here in Champaign. Okay, but if you don't have the patience, I do recommend that you try to travel a bit, and hopefully the weather will be nice and you'll be able to enjoy it. I want to leave some time now for some questions, and so yeah, let's see if we have any questions. You can unmute yourself, or you can just oh, I think I wasn't actually sharing my screen, was I? Let me just do that quickly so that you don't miss what I was sharing. What I was sharing here was just the map of that eclipse in 2153. You can see it passes through Champaign, so it's just kind of exciting. The fact that we can predict eclipses up to 1,000 years into the future is actually pretty amazing too. It took us a long time to develop that level of detailed knowledge. Okay, so yeah, now is a good time for me to take questions if anyone has any. Let's see, Ian asks, when is the best time to watch in Champaign? There's another site called timeanddate.com, which I always use just to find out what time it is in Paris or Jakarta. But in fact, they have a nice eclipse page too. So if you tell it where you are, it will tell you exactly when the eclipse starts, when the eclipse is going to be deepest, and when the eclipse ends. So this is all central time. And you can see that if you want to see the darkest part of the eclipse from Champaign, it'll be around 2 o'clock in the afternoon. Okay. Yeah, any other questions?
So
No?
anyone feel free to unmute yourself. One
Mhm.
question will be cold.
Or will it be cold? Probably not because the totality is so short. It's only like 3 minutes that it's not enough for the temperature to change a lot. But it really depends where you are. So if you're watching the eclipse from someplace dry or someplace on a mountaintop, then you can really experience more of that sort of cold breeze because the temperature is just so responsive to the sunlight. Whereas in a more humid location, you won't notice so much difference. Yeah, great question. Did anyone here actually watch the eclipse in 2017? Yeah, okay. Some people are nodding. Yeah. And so, yeah, any comments about that? Things they expected, things they didn't expect?
I guess I will share. I thought it was very cool because it's it's during daytime, but it's kind of dark, but it's not cloudy. So the entire feeling is very weary.
Yeah, yeah. Where did you go?
Oh, I was in town. I was driving on Florida. Um so yeah, I was in my car, but it just felt very different.
Uh-huh, uh-huh. Okay. Yeah. Yeah, we went down to Goreville, which is in the southern part of Illinois. And so yeah, every eclipse is different. So I think yeah, you can find information about all of these different eclipses. It's actually amazing that people have gone and made these tables of eclipses centuries into the future. So, but yeah, here's some pictures from 2017 showing some really amazing pictures that people took.
Yeah, we were trying to go to Southern Illinois to Garden of the Gods.
Mhm.
And my memory was it was so crowded and took a long time to drive. And
Mhm.
then I wish I knew better. I wish I had listened to something like this today because we ended up with no glasses and we didn't really know. We were just like, oh, it's so fun and all that. Let's go. So we went there and we were told that it's not safe. But I don't have anything safe. Um, Fortunately, there was the older lady. She was so generous and nice, and she looked. And after a few minutes, after she was done, and she gave us her glasses, so I get to take a peek at the whatever
Mhm.
is left.
Mhm.
So yeah, that was amazing. Still,
Yeah, and because it's the totality is quite close to Champagne, we're going to see 98% of the sun blocked in Champagne. Again, it's not quite as exciting as a total eclipse, but it's still quite interesting. And I think even if you don't want to deal with all of the traffic and the congestion, just take a break that day if it's sunny and go outside and enjoy the experience because it is something very different. The other thing people notice during eclipse is that the shadows of everything become much sharper
huh?
because the sunlight is not coming from the entire sun, but just only a little very narrow piece of the sun. And so that produces more sharp looking shadows than normal. So that's another thing that you can enjoy without having to go to totality.
Yeah, this round we're going to further down south to Texas. We're going
Mhm.
to Dallas. To
Yeah.
We looked at the map and just judging by the whatever it is called, the one of the best places to see
Uh-huh.
the totality. So
Yeah.
that's the reason we picked Dallas.
Mhm.
Um, and then this round, I'm going to go to Champaign Library to pick up a pair of glasses.
Mm.
um,
Yeah,
Yeah,
yeah.
just
definitely.
talking about glasses, and everybody who joined today's workshop, and you can get two pair of glasses, Eclipse glasses, at Champagne Library this Saturday afternoon. So please come
Well,
at
that's
3 o'clock,
great.
Saturday afternoon, 3 o'clock. Go to Robinson Room C.
Okay,
All right, so welcome, register early and also listen to the workshop late. So come to the library and we actually have another event during that time. And so you can really enjoy some special tour at the library.
great. Thank you.
Yeah, we have quite a few glasses we are giving out, and so Helen's going to take care of that. There are also a lot of different apps that you can find on your phone, including something here called the Solar Eclipse Timer. And these are free. And these are kind of handy because, it's your phone, so it knows your location. and it knows the time. So it'll tell you, oh, you're 5 minutes from this part of the eclipse, or you're 5 minutes from that part of the eclipse. It'll just remind you about things during the eclipse, so you don't have to worry about it. So if you're interested in watching the eclipse, you can download one of these smartphone apps too.
Cool.
Tony, we have a couple of questions in the chat.
Mhm. Oh, what kind of experience would it be if the sky is cloudy during the solar eclipse? Well, it depends how cloudy it is. If it's pouring rain, then it will just seem like a darker rainy day than a normal rainy day for a few minutes. But if there is some amount of cloud, but not completely overcast or completely dark, you can still get a fairly interesting experience, I think. I have not experienced this myself. I'm only talking about what other people have described to me. But because, we have this spot moving across the earth, as that spot approaches you, it will actually change the color of the clouds. So even if you can't see the sun, you might still see the dark spot coming over you as you're in totality. So it can still be a very interesting experience, although it would be much more fun to be able to see the sun. Um, and then yeah, Terre Haute. Well, yeah, we have uh, a group of people going to a college in Terre Haute. Let me see if I can point it out here on the map. Are you seeing my map? Yeah, so Terre Haute is not quite in the middle of the eclipse path. It's kind of off to the side here. But it's still getting about 3 minutes of totality. One of the nice things about Terre Haute is that it's relatively close to Champaign, so you don't have to use the interstate. In fact, there are lots of little roads you can take. So I'm hoping that there's going to be a way to get home. We'll see. Uh, yeah, we're going to be visiting the Rose-Hulman Institute of Technology, which is going to um, have a sort of a celebration for the eclipse. And so, yeah, we are going to get to look through some of their telescopes. They have a little observatory there, so that's going to be quite exciting. Unfortunately, they haven't allowed us to advertise this to everybody, so we can't invite everyone to go there. But there is going to be a festival in downtown Terre Haute with lots of people and food and entertainment. So they're going to basically have a big celebration in downtown. But another place which is having a lot of events is down south of Terre Haute, Vincennes. This is a small town, but you'll notice it's kind of special. It's right here in the middle. So it gets the longest totality. And they're going to have the best darkness as well, because if you're at the edge of the path, then you're actually pretty close to these other places which are still in daylight. So it doesn't get that dark for you. So people that really want the experience of darkness are probably going to go to some place like Vincennes. And you can actually check out their website. They have some pretty fancy stuff here going on. They've uh, set up places you can purchase parking for 20 bucks. Now, 20 bucks for parking is not that crazy for going to Chicago, right? I mean, these people think it's amazing to be able to get $20 for a parking space. But if you're interested in watching something, it's a reasonable price to pay. And so, yeah, I'm sure a lot of people will be going down here because they're going to have the longest duration of totality in Vincennes. So there are a lot of options, and I guess my main advice is to try to stay flexible, right? If you put $500 down on a hotel room and it turns out that it's raining that day, you're not going to feel very happy, right? So if you're willing to be a little bit more flexible with your time, and I know it's hard because of work and school, but probably 48, 72 hours in advance, you'll have a pretty good idea of the weather, and then you can try to target where is going to be a good place to go. Oh, the question about binoculars. Yeah, so what I did here was I just basically went to Amazon and I bought these filter papers. They're just these square, shiny sheets of paper that you can put on the binoculars to darken them so that you can look at the sun safely. So that's one thing you can do if you want to see the sun more clearly, because if you don't have binoculars, the sun will still appear quite small. So the binoculars make it easier for you to see what's going on. And they have like filters like this for telescopes too, if you have a telescope.
Professor Wong,
Mhm.
I looked up some sites like the NASA site, and I noticed that they're calling this one the Great American Eclipse. Why
Mhm.
is it called the Great American Eclipse? What made it so great?
Oh, well, people just like to have fancy names, I think, right?
Okay.
Yeah. In
All
fact,
right.
I think that it's the 2017 one is probably more properly the Great American Eclipse if you think about the United States, because only the United States got to see that. Whereas
Oh,
this eclipse is going to Mexico and Canada also. So it's actually the Great North American Eclipse.
okay.
Yeah. But yeah, people will say all kinds of things just to get some publicity nowadays, right?
Huh.
Okay. So yeah, I certainly recommend that you check out some of these websites, including EclipseWise, Great American Eclipse. There's lots of information and maps there, and you can use that to help plan your travel or whatever you want to do during that time.
All right,
Okay,
thank you so
and
much, Dr.
yeah.
Wang. And so with that, I'm stop the recording. I really appreciate all your help.